Okay, so with this homework, I think the mistake a lot of people made was not treating it with non-calculator methods. They were either using calculator methods that took ages to do in their heads, or they were just cheating and using shortcuts. So I'm going to talk through the way of doing these properly and try and make sure that you've learned these because these will obviously come up on non-calculator papers. So, first question, we want to see the greatest value. Generally, you want to convert things to the same sort of number. I'm going to convert them to real numbers because I've already got 61,499. So let's go through. Remember, the power of 10 tells you how far you're going to move your decimal place. So our decimal place starts between the 6 and the 1, and it moves once, twice, 3 times, 4 times. Then we fill in the gaps with zeros. That's 61,500. Do the same thing. Once, twice, 3 times, 6,200. Same thing, and remember the decimal place starts between the 1 and the 6 now. Once, twice, 3 times, 61,600. This is our biggest number. Second question, 800 million in standard form. If I have a number like that, I'm probably going to try and write it out before I do any sort of conversion. So a million is 6 zeros. And then if we think, well, we've moved the decimal place once, twice, 3, 4, 5, 6, 7, 8 times 10 to the power of 8. 3, similar sort of question, smallest to largest, so we want to change them. Remember, when you've got a negative number, you can just take that as the number of zeros that are at the front. So because that's an 8 times 10 to the minus 4, we can write 1, 2, 3, 4 zeros at the front. Or we could do it just by counting decimal places again and saying, well, it started here once, twice, 3 times, 4 times. We can do the same thing for the other numbers, so we'll get 0.04, 0.0006, and 0.07. And then from smallest to largest, the smallest number is 6 times 10 to the minus 4, and then 8 times 10 to the minus 4. Few people got those the wrong way around, having identified they were the smallest two numbers, but not sure which one was smaller than the other. And then our last two numbers, 0.04, is smaller than 0.07. You normally want to write these in terms of how the question gave them to you. Question 4, it says we need to write again a number in standard form. I would always write this out. So this is 6,005,200. So that's 6.0052 at the start, and then we've moved the decimal place once, twice, 3, 4, 5, 6 spaces. So times 10 to the power of 6. Then we go on to 5a. Now we went through methods of multiplication and division, which I'm kind of expecting you to use, again, as it's non-calculator. You can write these out as whole numbers, you can multiply them together, you can change your answer back to standard form, but it is easier to do the following. Multiply the numbers, so we'll go 2 times 8, and that's 16, and then add the powers. So if we go 10 to the 6 times 10 to the 4, we'll get ourselves 10 to the power of 10. So our answer here is 16 times 10 to the power of 10, but this is not in standard form because 16 is bigger than 10. So what we do is we reduce that to 1.6 and we increase the power to 11. So 1.6 times 10 to the 11 should be your answer there. B is a division, and the way we set this out is we divide the numbers, so 2 divided by 8 we're going to need to do, and then we subtract the powers, so we're going to need to do 6 minus 4. 2 divided by 8, well, that's a quarter if we simplify it, so that's 0.25. You don't actually have to do a bus stop there. And then 6 minus 4 gives us 10 to the power of 2. Again, this is not in standard form, but actually it doesn't want it, it wants it as an ordinary number. So let's do that. So that means we're going to need to move the decimal place twice. So once, twice, that'll give us 25. 3, it's another multiplication. So we're going to go times the numbers and add the powers. Times the numbers 18, add the powers 3, and then adjust. 18 needs to decrease, so the power needs to increase. Okay, we're going to do the same thing on the next couple of questions, but remember those basic ideas. Next one, we've got an addition. Now additions you can do in a variety of ways, but as these have the same power, we can use the shortcut of just adding our numbers together. This is 12 times 10 to the 4 in our bracket, and we want to divide it by 24. Now, there's a lot of ways you can approach this. I would still use my standard form way, which is to divide the numbers. So I'm going to do 12 divided by 24 and then subtract the powers, and there's nothing to subtract from the 4, so it's just going to be times 10 to the 4. 12 over 24 is a half. So that's a lot simpler now, and that would mean this is 0.5 times 10 to the power of 4. Not quite in standard form, which is what the question asks for, so we'll increase this to 5 and we'll decrease this to 3. And there you go. 7a, a little bit easier, standard form, so 1.25, and then the decimal place has moved once, twice, 3 times, 4 times, so times 10 to the 4. Minus number on the power means we can just write 2 zeros at the front and then 3, 4. 4 zeros at the front, so this is times 10 to the minus 4, and it's 5.83. And this one we want to move 5 spaces, so if we've got 9, 4, 1, 6, we're moving it once, twice, 3 times, 4 times, 5 times. It'll be 941,600. Lastly, C, I would prefer to do this as a sort of standard form question. So let's do that. I'm going to say that I want to divide the numbers, so I want to do 7,200 divided by 300, and then the power is a million, is just 10 to the 6. I can cancel out these zeros. Essentially, I'm dividing top and bottom by 10 to do that. So it's actually 72 over 3 that I want, and that's 24. So 24 times 10 to the 6, but we want this in standard form, so 24 has to decrease to 2.4, and 6 has to increase to 7. Okay, number 9, we've got an addition, and this time the powers aren't the same, but actually it's not an addition, it's just spotting what the number is. This is 24,240, and we can rewrite that as 24,000 plus 240. So this is 2.4 times 10 to the 4 plus 2.4 times 10 squared. So it's in this form that they've asked it for. And our value of A is equal to 2.4 for whatever it's worth. I don't think you end up using it, but there we go. It says you actually need to work out A times 10 to the 4, so that's 24,000 again. Take away A times 10 squared, so take away the 240. So if we do that, we'll get 23,760, but it wants this in standard form, so 2.376, and we've moved it once, twice, 3, 4 times, so times 10 to the power of 4. Okay, last couple of questions. An easy starter for 10. We've got 3 decimal places at the front. This is a division, so we want to do 1.8 over 9, and we want to do 10 to the 5 over 10 to the 2. So 1.8 over 9 is 0.2. 5 take away 2 is 3. And then adjustment needed, so make 0.2 bigger and make 3 smaller. And it wants to be in standard form, so we're done. For 11, solving an equation. Okay, so this looks complicated, but all you really have to do is divide by this bracket. So we're going to do 1.8 times 10 to the 8 and divide that by our 2 times 10 to the power of 5, and that should give us what x squared is. Now, again, we want to approach that by dividing the numbers, so 1.8 over 2, and subtract the powers, so 8 minus 5. That'll give us 0.9 times 10 cubed, which doesn't say anything about answering in standard form, so let's change that to a number. So if we had 0.9, moved it once, twice, 3 times, that would mean our answer is 900. That's what our x squared is. But we want to solve it, we want to find x. If we know x squared, then we need to square root 900, and that is 30. But remember, a square root can have a positive and a negative answer, so the other answer is minus 30. Well done if you got that one. I think that's probably the trickiest one on the board. Then question 11, we're just writing the number in standard form, so 1 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, so times 10 to the minus 6. 5 times 10 to the 13 as an ordinary number is huge, so it's just going to be a 5 and then 13 zeros, which is annoying to write, but is, you know, it's fine. So what number is that? That's 50 trillion, I think. And then C, we've got 4 cubed body cells affected on day 1, and then 210 is when it becomes serious. So there's two ways of approaching this, so I will show you both. First way would be to work out what these numbers are. 4 cubed is 4 times 4 times 4 is 64. 2 to the power of 10 is 2 times 2 times 2 times 2 times, well, do that 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And, you know, it's going to take a while. We go 2, 4, 8, 16, 32, 64, 128, 256, 512. That's 1024. And your method could be that you say, okay, well, on day 1, we have 64 infections, apparently. And then every day it doubles. So by day 2, we'll be at 128. By day 3, 256. By day 4, 512. And by day 5, which is our final answer, we'll be at the 1024, where the disease is now serious. However, there is a slightly cleverer way of doing this that doesn't involve doing loads of sums, which is to rewrite this as powers of 2, and this is part of what you've been doing this week. So I'm going to write these both as powers of 2. I've got 4 cubed here. Now I can rewrite 4 as 2 squared, and then I can use the multiplication rule to say, well, that's 2 to the power of 6. So that's day 1. Now, if every day it doubles, so if I times that by 2, it's just going to increase the power by 2, because instead of having 6 2's times together, I've now got 7 2's. So day 2 is 2 to the 7, day 3 is 2 to the 8, day 4 is 2 to the 9, and day 5, which is again our answer, is 2 to the power of 10. But either way, our final answer there is day 5. So yeah, have a look through, make any corrections, and really look at those non-calculator methods if you did use any shortcuts. Cheers.